There. When I did my middle school class earlier today, I started recording right away, but then I forgot to share my screen, and so I started talking. They let me go for about 2 minutes before they finally told me they couldn't see anything. Oh, since it was there, I might as well share it with you. My middle schoolers were learning about what was it? Oh, they're learning about area and circumference of circles, and so I remember one of my friends shared this meme on Facebook, and I thought it was funny, so I showed it to my class. And then they called me a boomer. Told me it was a boomer meme.
Boomer.
I reminded them I'm like half of the age of a boomer. So, oh, I forgot to cross that off. We did that one yesterday. So, we are going to be finishing section 2 today, and that is going to be kind of like what I already said to Adam. He was wondering, and I'm sure some of you as well have been wondering, how come sine doesn't pair with cosine? How come cosecant doesn't pair with secant? Well, today we're going to address that. They actually do pair with each other. It's just that they have a different relationship than what we've talked about so far. And that is that they are co-functions of each other. So, like I was just saying, you can see sine does go with cosine here. In this case, secant with cosecant. And then the special one, tangent is still pairing with cotangent. There's no change there. And another way, the book actually prefers this terminology. It says that they're complementary. So that's another way that you could see these. So I'll give you just a little bit of time then. Okay. What I'm going to do now is I'm going to show you how all of these relate to each other, like what's the importance of their relationship. So like many of the other things that we're doing, we're going to use SOHCAHTOA and we're going to use a right triangle. So we're going to use this triangle down here at the bottom to answer these two questions. First, what is sine of A? And then what is cosine of B? So can somebody tell me give me the ratio for sine of A according to the triangle?
AC.
Yeah, so it would be A over C. Sorry, both me and my wife are now going outside because we just heard a car horn going crazy. Oh, that's not interesting. And I was hoping for some people fighting outside. Didn't want a parade.
Poor birds.
Yep. So, as Adam said, sine of A is going to be A over C. Now, what is cosine of B? So again, from our triangle, what is the ratio for the sides that makes cosine of B?
Adjacent over hypotenuse?
Yeah, so it's adjacent over hypotenuse. So use the letters in the picture.
Oh, B over C?
Okay, make sure you're using it from angle B though.
Oh, where's that? Oh, got it. Okay, so A over C.
Yeah, so this also is A over C. Now this next part then is saying A plus B equals 90 degrees. I hope you would all agree with me on that. Because we've got the right angle there at C. And if we added all the angles together, 90 degrees plus A plus B will equal 180. So of course, if we subtract 90 from both of those, we're going to be left with A plus B equals 90 degrees. So that's how I know that is true. So if we then rewrite this equation here and we solve for B, that means that we're going to subtract A from both sides, and that leaves us with B equals 90 minus A. Now, up at the top, we have sine of A is equal to A over C. Cosine of B is equal to A over C. But we've now said that B is the same thing as 90 minus A. So therefore, we can now take these two things and write that they're equal to each other by using the same angle. And that is down here, sine of A will be equal to cosine of 90 minus A. Now, I haven't taught you how to use your calculator in order to solve these yet. I will do that, just not yet. But we could use our calculator to check that that is correct. But also, if we just draw a triangle like this, we can use the triangle as well to confirm that they are the same thing. So that is the first set of cofunctions, sine and cosine. So if it's okay with everybody, I'm going to move on then to the next one. So we're going to do a similar thing here, and this time you can probably make a prediction because it's going to end up being similar for tangent and cotangent, and then secant and cosecant, we're going to do it the same way too. So in our triangle, what is tangent of A equal to? So again, I'm looking for this one. What is tangent of A?
A over C.
Sorry, can you say that again? I only heard
A
the first
over
part.
C.
So I agree with the A part, but tangent is opposite over adjacent.
Oh, B.
So A over B, yeah. Okay, and then how about cotangent to B? Some of you could probably recognize the pattern of what we're going to have here.
Is that also A over B?
Yeah, it's also going to be A over B. And then this time I didn't bother leaving a blank because we already knew that B is equal to 90 minus A. So that brings us then to the second equation, which is that tangent of angle A is going to be equal to cotangent of 90 minus A. Okay, and then I'm going to move on to the last one. And this is going to look just like what we did before. This time we're doing secant of A. So this might be a little trickier since we usually don't ask for secant, cosecant, and cotangent as often. But is anyone able to tell me either secant of A or cosecant of B?
Is it A over B? Oh, wait, no.
What?
Yeah, it's not going to be A over B. So what may help is remembering either what is the reciprocal for secant or what is the reciprocal for cosecant. Or perhaps also, what's an alternate way to write secant? What is an alternate way to write cosecant?
Is it C over B?
Yes, there we go. Good. So secant is going to be 1 over cosine of A. And cosine of A is the adjacent over the hypotenuse, so that's normally B over C. But then we want the reciprocal of that, so it's going to be C over B. And then for cosecant, that is 1 over sine of B, which means that we would use opposite over hypotenuse. Once again, we get B over C, but the reciprocal means that we have C over B. Awesome. Therefore, that gives us the last one, that secant of A is equal to cosecant of 90 minus A. I should have mentioned this earlier, I suppose, but this, if you were wondering, this is also true. If we were to switch secant and cosecant, we still can say the same thing. So, and that's true for the other two equations I showed you. So you could switch sine and cosine, that's still going to be correct. You could switch cotangent and tangent, that will still be correct. Okay, can I move on?
Yeah.
Now, I personally think that the book made it a little easier because it told you exactly what the trig functions are. But what I want you to do, go ahead, use the formulas I just showed you and solve. Then you're supposed to give the missing angle measure then for all the blanks. So just use the formulas to help you. I'll give you maybe about a minute or so, and then I will show you how to do these. Oh, and then I'm going to go fill up my drink, so I'll be back in a second. Okay, now that I've filled up on Arizona green tea, I'll be good for the rest of the class period.
What about kidney stones?
Hopefully they hit during the summer then. So I
Dang.
don't miss school. you know what? Because of the concern, I did change it up the last time I went to the grocery store. I actually bought some iced tea as well, and
Purely kinky.
because that's what happened last time, was that the doctor told me the problem was I was drinking too much of the same thing, and then I had to change it up to other stuff. And so he told me iced tea and lemonade would have been easy things to switch to. So I tried doing that. The problem though is that all the bottles of iced tea are much smaller, so I go through those faster. Okay, enough talking. So for these questions then, all you had to do was just 90 minus the angle measure. So for the first one, 90 minus 23 is going to give us then 67. For B, 90 minus 40 gets us 50. And just so on. You're going to keep doing the same thing, just 90 minus each of the angles to solve them. I personally would have preferred having all of you try to name the trig function that matches with them too, but I guess the book disagreed with me on that.
Thanks, book.
Yeah, the book took it easy on you.
For the first time in forever.
Yep. Okay. So moving on from this then. Now, the notes didn't have these questions, which was really strange because they show up in the homework assignment anyway. So I'm going to help you with these just so you know what you can expect. There were 4 of them in the book. I'm actually just going to assign 2 of them for the homework. So what we're going to do now is we're going to use the formulas that we just learned to simplify these. So this is going to be similar to what we were doing yesterday as well. So like for the first one, part A, I see that we have cosine of 90 minus x. I got lazy. I should have put degree symbols in there. But anyway, we know that cosine of 90 minus x is going to be the same thing as sine of x. Because again, that's from the formula way at the beginning. There. From this formula here, cosine of 90 minus a is equal to sine of a. So we can do that for our first step in this question down here. Then we still have cosecant of x. And what is cosecant of x equal to?
Secant 90 minus x.
Oh, okay, good. Not what I was looking for, but yes, that is correct. What I'm actually, I'm sorry, I should have been more clear. What I'm looking for is what fraction is the same thing as cosecant?
Isn't it 1 over sine?
Yeah, there we go. Sorry about that. I should have been more clear when I first asked that question. Okay. And what happens then when we multiply sine times 1 over sine?
1.
1, exactly. Because those 2 will cancel. So yeah, that's kind of interesting that for part A, our answer is just 1. So we're going to do a similar thing for the other 3 as well, where we're going to either try to change one or both of them and then use that to hopefully simplify into something easier. Tried taking a sip of green tea and spilled it on the couch. Whoops.
Oh, snap.
Yep, not good. Anyway, okay, so for part B, I see tangent of 90 minus x. So from the equations that we've just learned, we know that that is going to be the same thing as cotangent of x. And then cosecant, we know that that is going to become secant of x. And then we can simplify this further. What fraction is cotangent equal to?
1 over tangent.
1 over tangent. And what is the other fraction as well?
Cosine over sine.
There we go. Yeah. So we got cosine over sine. And then what about secant? What is that equal to as a fraction?
1 over cosine.
1 over cosine. Good. And now I see that we can cancel cosine from the top and bottom.
You get sine.
Yep. And then make sure sine is on the bottom. So we have 1 over sine. And what is equal to 1 over sine?
Cosecant?
Yes, good. So for B, that's simplified into cosecant of x.
Briz, I have a question.
Yeah, what's up?
I don't know if this is like, obvious or not. So like, you know how like the tangent 90 minus x is equal to cotangent?
Yeah.
Are we supposed to like we're supposed to know that, right?
Yes.
Okay. All right. That was just my question.
Okay, no problem. I do promise though, the questions will not be much different from either these that we're doing right now or from these. Actually, from the homework, the questions are exactly the same as these two sets. And then if / when / who knows for a test in the future, they would still be like this as well.
The homework was kind of hard.
Yesterday's?
Yeah.
Yeah, I could kind of tell when I was teaching all of you yesterday. I could tell it was very tricky.
Was yesterday the only day we were learning that? Or are we gonna do it some other time as well?
I mean, we're doing it with these questions right here that you can see, but that's really it for IM2. We're not going to do much. We're not going to do much more with that.
Yes.
I ended up teaching that partially because there were questions like that in the homework, and I was a little frustrated that the notes didn't address it at all. It kind of made it seem like it was something that you all were just supposed to know. So that's why I made sure to spend a day on it, was so that at least I could show you how they are supposed to be done. Okay, so not all of these, well, I shouldn't say that before part C, but sometimes these don't simplify as nicely as we wanted. And so C is not exactly an example of that. I think D might be though, but I'm just going to demonstrate here. So we know for C, cosine of 90 minus x, well, we already did that for part A. We know that that is going to be equal to sine of x. And since we've got two of them, of course, something times itself is just going to be that thing squared.
Crap.
Adam's having problems.
I used the wrong pen.
Oh, okay. Don't do your math in pen.
All my periodics in your class were in pen.
I'm aware. I'm pretty certain also you use the same blue pen that I use, so I had to switch to a different color too when I was grading it.
Oh God. Whoops.
So anyway, for part C then, when it's sine times sine, we can just simplify that into sine squared. And then for this last one, we'll do orange. Secant of 90 minus x, that's going to become
That is-
cosecant. How can I rewrite these two now? What fraction is equal to cosecant and what fraction is equal to tangent?
Tangent is 1 over, wait. 1 over cotangent?
Yeah, it's 1 over cotangent, and then let's use the other fraction though. So what's the other way that you can write tangent?
Sine over cosine?
There we go, yeah. So let's use sine over cosine for tangent. And then what is cosecant equal to?
1 over sine.
Yeah, 1 over sine, good. Now this is looking a lot like B, except this time the sines are going to cancel rather than the cosines. We get 1 over cosine. And then what is 1 over cosine equal to?
Secant.
Good, yeah, secant. And so there's the answer for the last one. Yeah, so on the homework, I am going to have you do 2 of the 4. One of the ones I didn't assign actually didn't simplify really well. I think the answer ended up being like sine times cosine. And it's kind of like, well, that doesn't look that special. But at least all the ones here simplified into something pretty nice. So that is it for everything here. Yeah, I made a mistake. I had downloaded it to my iPad, then I made my answer key, and then I just got lazy and was like, instead of downloading it a second time, I'm just going to keep it like this. So now don't be intimidated by 24 here. That all of those questions right there are just like this here, so you just have to put in the angle measures. So that shouldn't take very long. And then just 18A and B are going to be like these that we did here. So that's everything. We're done 15 minutes early.
Thank you.
You're welcome. Have a good day, everybody.
Bye. You too.
You too.
Bye.
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 Bye.